Let's look at various different C++ data types in the Upshot. So we saw chart. So chart is a universal 1 byte character data type. This one is cross platform. So regardless whether you're on Macintosh, Windows, or IBM, Solaris framework, and this size of chart is always 1 byte. There are also implement specific types that you see in C++. These types are more Windows specific. So if you use Visual C++, you'll see implementation of char16_t. So this represents a 16-bit char, right? 16-bit is 2 bytes. So this is 2 bytes. You also see 32-bit, which is 4 bytes char. So these are what we call wide chart, okay, wide string or chart, right? We also have narrow, so this is a narrow one. Anyway, so once you get into C++, you'll see various different types. So remember though, these all represent different things. So this wide chart is typically part of your std w string, okay? So this is a wide string. So this could be either 2 bytes or 4 bytes. Okay, so I won't get into too much details here because this entails pretty advanced application and understanding of what we're doing with this, right? Just remember, for the purpose of this class, we'll be using char. There's also type modifiers that you see in C++. We saw sign and unsigned, right, earlier. There's also short and long, as I stated earlier before in the previous slides. So what these type modifier do is to make the existing data types slightly bigger and smaller, right? Depends on what you have. So short means if you have a short in, so integer is 4 bytes, right? So if you put a short in front of it, this entire short in is a 2 byte, okay? And long in this case, on a contemporary computer framework you're running this on would be 4 bytes, actually 8 bytes. Right? Why? Because integer is 4 bytes. So if you make it long, then it's 8 bytes. So with these modifiers, you're able to make your storage slightly larger or smaller, right? Depends on what they are. Float here is at least 4 bytes. Okay, so this is as big as an integer. And basically what you have here is a float with a 7-digit precision. Double is 8 bytes. Okay, so this double allows you to store up to 15, 16 digits. After an integer. So long double, it turns out this long double is 12 bytes, right? So it didn't just double, right? It didn't just double the double by being a 16, but if you have a long in front of it, it's actually 12 bytes, at least 12 bytes. So a lot of these are implementation specific. So it depends on which framework. So if you don't know what it is, you want to size off, okay? Do a size off. And try to see out whatever that type is to double check. You also have Boolean. Boolean is 1 byte, like I said before. The smallest unit that the computer CPU can interpret is byte. So Boolean is 1 byte, not 1 bit, okay? Even though Boolean is 0 and 1, you could represent it in a bit, but we cannot do that. The smallest computing unit in computer is byte. So Boolean is assigned a byte. A void is also a data type. So void is valueless. You don't store any values to it. Okay, so you can have something representing null, as a return to the previous callers, right? So this is through a function return type. So you can return null, or you can just return as is. A void simply, it's a placeholder for a function indicating that there is no return type, right? But at the most, you can still return null. It will be fine. But usually people just do return, right? To indicate that, hey, this function doesn't return anything with a void, right? Type as a function's return type. Okay, so this is a quick illustration of C++ data type, where we go into more of discussions on how we can cast this info and how these informations are used in C++.